All right, assignment number 28. Again, finding the area of a plane region bounded by two functions. And this would be example 2, part A. So we have y equals x squared minus 3x, and we have the x-axis. All right, what this is testing is your ability to remember that the x-axis actually has an equation. All right, so let's see, here's your x-axis. Now, it's a horizontal line, x-axis. And isn't it a line where all the values of y are equal to 0? You hopefully would recall, and if not, that's what I'm here for, that it's like, hello, my name is x-axis, but my friends call me y equals 0. That's another name for the x-axis, is the equation y equals 0. So really that's, frankly, the only curveball that's being thrown here. We have two y equals equations, all right? X-axis, aka y equals 0. So look, we're back to the same things we were doing before. As long as you remember that, you're good to go. And so if you set these equal to each other, in the interest of space, I'm going to erase x-axis and put y equals 0 up there. It's given name, all right? So y equals 0 is another name for the x-axis. Now we set the two equal to each other. So x squared minus 3x equals 0. Solve it. Oh, look, you can factor out an x. This is just algebra. Employ the zero product principle. This is all just algebra. I got to do it fast. X would equal 0. X would equal 3. I told you guys at the start of the semester back in January that when we get to the just algebra, I reviewed it with you at the start of the semester. Now we got to do it, all right? So x equals 0, that'd be 0 right here, and then 3 over here on the x-axis. So we're basically, hopefully, if we did it right, these two graphs cross at 0 and 3. I like to confirm, as you've seen on the previous examples, watch these in order. So if we put 0 in for x over here, 0 here, 0 here, it's all going to be 0. And if we put 0 in for x over here, there's no x in the equation, so y would equal 0 immediately. And so that ordered pair 0, 0. What's that called, you guys? Origin, yes, that's right, good. Origin, 0, 0. All right, on the other end of the spectrum, 3. If you put 3 in for x, 3 squared is 9. 3 times 3 is 9. 9 minus 9, 0. And if you put 3 in for x over here, we think too much, there's no x. Isn't y always going to equal 0 on that equation? Notice again, they're the same. So 3, 0 would be another one. Okay? Look, if you understand what these graphs are, and maybe you don't have to do some of these steps, but I'm showing you something that would work no matter what the functions are. My next suggestion would be to pick a number in the middle. That's why I left a gap there. Oh, this time you can't test 0 because it's your end point. You got to pick a number in the middle. How about 1? That's in there between 0 and 3. Let's make that the test number. If we put 1 in here for x, we're going to have 1 squared, which is 1, and negative 3 times 1. It's arithmetic! 1 minus 3, that's going to be negative 2. I hope that's correct after I mocked it. All right? And then if you put 1 in here for x, y is 0. So you look at those two numbers. And again, the reason for testing that is to find your upper and lower. And I don't know if you can see the colors very well on the video, but upper green, lower red. But you would hopefully look at the 0 and say that's a higher number than the negative 2. That's the whole point in doing this. Which one gave you an upper value of y? And 0 is above negative 2 on the y-axis. That's the whole point of it. Point. Get it? All right. So anyway, hey, y equals 0, you're actually called f of x now. And you're called g of x. Upper, lower. There we go. You don't have to label them to do the problem as long as you set it up right, but I want my labels to match the general notes. F of x upper, g of x lower. It's very mechanical stuff. Honestly, let's see, this is just a horizontal line, right? X-axis as it was described at the beginning of the question. And then this goes underneath it, doesn't it? So it's down here somewhere. By the way, it's a parabola, it's not curvy crazy. But doesn't matter that your picture be perfectly accurate, just where do they cross and which one's above the other over that interval. So the area here would be the integral from 0 to 3, upper 0, minus lower. It's important to put it in parentheses so that the minus would apply to the entire expression. This is just mechanical stuff now. Let's simplify this in terms of distributing and so on. It looks to me like before we go do calculus, let's simplify this in terms of distributing the negative into that second quantity. And of course, the 0 goes away. And here we go. And then it's time to integrate, evaluate, celebrate, graduate, and compensate. All right, so the integrate part of that would be to find the antiderivative of that function there with respect to x. And this would be negative x cubed over 3, n plus 1, n plus 1, plus 3x squared over 2. We have to take for granted that finding the antiderivatives, the integrals of terms is old stuff. And then this is from 0 to 3. And look, I'm going based on what former students have told me. Stick the numbers in, right? Evaluate. And you stick the numbers in, I wave my hands in the air, hit pause, do it, or work ahead of me. I don't care. You should end up getting for this, I did the arithmetic ahead of time, 9 halves, 4.5. I don't really care which one you choose to give me. All right, so there would be that one. Again, I would tell you that the only little trick on that was identifying the fact that the x-axis is otherwise known as y equals 0. Cool.